Well, thank you for having me here. And actually, officially, I became past president at the Sydney meeting. So when I was scheduled, I was the president, but now I'm past president. Feels good. So this is a repeat of my IMS Presidential Address in Sydney. And the title is Let Us Own Data Science. So this is one graph I found from the internet that I think kind of fits with what I think data science is. And there was a discussion afterwards with some young people about, is that a union or is that an intersection? But I think that's something we can discuss. But I think all the ingredients are in there. We have statistics and mathematics, computer science, and domain knowledge. And here defined as the intersection. That's kind of the idealized data scientist should know all three, but I think nobody really knows all three right now.
Oh, Ben, what's engineering in here? Can you kind of just point where you think engineering?
I think it's probably, I can put computer science, ECS,
yeah.
And here you can, so social science,
yeah.
Science, and IT, so there. And here you apply math if you want to put it there. So remember, this was given in Sydney, so for those of you who didn't make it, that's to make you feel sorry. It was a beautiful place, and the Statistical Society of Australia Incorporated and IMS, we gathered, had a wonderful time, about 500 people. If we turn the clock back 67 years, 1947, that was a picture from Sydney Harbour, Darling Harbour. And that's when the Australian Statistical Society started. So in University of Sydney, there was a group of people who started having the New South Wales chapter before the society came about. And the goal is to further the study and application of statistical methods in all branches of knowledge and human activity. The first president was actually a woman, Helen Newton Turner. And she, if you look at Wikipedia, was a statistician and a geneticist. From her obituary, it reads that Helen Newton Turner, the animal geneticist who spent most of her professional life working for the improvement of the wool industry, died this week, 1995. Not many scientists in Australia have contributed as much as directly to the growth and well-being of major Australian industry as she did. Not that she would have agreed with his description. She was a very modest woman and would have said, it wasn't me, it was my team. So you can see it was all collaborative already. And she started with CSIRO, and later didn't want to be a consultant and want to become a scientist herself, so she became her famous book, Quantitative Genetics in Sheep Breeding, it was very well known, and there were three major contributions she made. The first was an experimental scientist, introducing objective measure methods into breeding, so a lot of design. The second was a communicator and publisher of the new methods. The third was an educator of postgraduate studies of students and Department of Agriculture staff. If you go further back, so essentially recognize that, where is that? 17 more years, Ann Arbor. Another picture from that era. The Annals of Mathematical Statistics was started at the University of Michigan by Harry Culver. He's listed at Wikipedia as a mathematical statistician, actually I listed that, and aero navigation expert. He got the decoration for exceptional service by U.S. Air Force, the most honorable mention at peacetime. And one thing I have to mention that if you really believe in what you do, you use it to choose where you're going to retire. He ran some criterion for ambient temperature, total rainfall, and things, and decided Santa Barbara was the best place, and she went there. He went there. And in his book, which actually I found a copy of when I was in Melbourne, Introduction to Air Navigation, logarithm was kind of the old method to do air navigation. He said, logarithm must be considered now as a tool of the past. Present-day commercial institutions, almost without exception, use computing machines rather than logarithm in the conduct of their business in the interest of efficiency in both time and labor. More progressive schools now have installation of these machines. So he actually got the first computing machine for University of Michigan. And he basically, I would say that he was doing online estimation, because if you fly an airplane, you don't have a lot of time to do a lot of calculations, right? You have to make decisions right there. And he was using mainly, I think, optimization, a little bit uncertainty measure to do this optimization to decide how the plane should fly. So it was very much, I would call online streaming data. And the machine was named after Hollerith, who was actually also a statistician and an inventor. He, because of 1890 census, was predicted to would have taken like 13 years to complete, and census every 10 years. So he was encouraged to look into a computing machine that he did with punch card and all that for tabulation. And he formed a company, later become one of the 4 companies formed IBM. So so statistics were right there, pushing the computing revolution. If you put all the trees of Turner and Carver, the 2 founding presidents of the 2 societies, together you basically get data science. You have statistics, domain knowledge, computing, collaboration between Wissing team, and communication, which Turner was great at to outsiders. So I call SDC3. And later, somebody very dear to Harvard, Cochrane, really developed a lot of sampling techniques. I think that's more well known than the fact that Discover, preparing for this talk, he actually started 4 departments around the country. Our state, NC State, Johns Hopkins Biostat, and Harvard Stat. So I think if we have that energy and vision, we won't have problem. Start 4, one person start 4 departments or 4 data science groups, we'll be all set. And he said that our knowledge, our attitudes, and our actions are based on very large extent upon sampling. This is equally true in everyday life and in scientific research. But when the material is far from uniform, as often the case, the method by which the sample is obtained is critical, and the study techniques that ensure trustworthy sample becomes important. I think this is actually a very overlooked area in data science, is how data is collected. And all the data now we use definitely not uniformly sampled, and that hasn't been taken into account. I think for statistical-minded people, this is a great area to contribute to data science. And later, the more well-known, I think people agree, he really was really a data scientist, John Tukey. And it could be a definition of data science. It was to be true that there will be aspect data analysis, well-called technology, but there will also be the hallmarks of stimulating science, intellectual adventure, demanding cost upon insight, and the need to find out how things really are by investigation and the confrontation of insights with experience. And he got a US Medal of Science and got a medal for invention for FFT. At the Wikipedia page, there was a description of Tukey's principle of statistical practice, and summarized their credit to A.D. Gordon, and was kind of more a paragraph, so I made it into a bulletin in my own words. I think this is really a good list of things for data science as well. Usefulness and limitation of theory, importance of robustness, importance of massive empirical experience of a method for guiding its use. So we have to emphasize this empirical experience, importance of data's influence on method chosen, rejection of the role of police. It's like we're not there just to please others. We have to do it and show examples. And resistance once for all solutions, over unification of statistics, and iterative nature of data analysis, computing and training. So I hope I made the case very clear that from the beginning, we do a big part of now what's called data science. And I don't think any other discipline does more, if you look at the whole umbrella of things, than what we do, right? Everybody owns a bit of it, and then we own just as much. So to fortify precision data science, I think we need to continue to emphasize on critical thinking. That's, I think, the very basic to do applies real-world impact statistics. And computing, I think it will be a separate talk. So the key here is really memory and communication. It's not really CPU. The game is not CPU anymore. It's about memory and communication. And here's also something which I think we really need to emphasize. Actually, that's why we have a panel today on leadership. Leadership, interpersonal, and communication skills. Without this, first, we will lose resource, or we won't get resource, and it will be hard to collaborate and hard for the public to understand what we do. For the Twitter generation, I have a simple message list. Think or think, compute or concede. I think last year I already said that in my JSM talk. Lead or lose. So let us just call ourselves data scientists. So what's the big deal, right? We already do, most people say, about data science. Because words do mean things. You say what you do, people have an impression what you do from what they think you do, and you might gain or lose opportunity. So the game of branding. Fields always evolve, right? Statistics field started mainly from census. And then we now do stochastic modeling, we do computing, we do lots of cancer research, we do lots of things. But we didn't change our name. So the meaning actually got a lot broader, but the name stayed. That's how we have used that terminology. Computer science took a different approach. New names or new development over time. AI, artificial intelligence, data mining, machine learning, now deep learning. Right, they have this catchwords. So suppose you imagine somebody you know, an 18-year-old Jay. I try to be gender neutral. And this young person wants to decide between statistics and data science. One thing you should know is that, that's something from my own research with the Galan lab, our brains are made in such a way that we get bored pretty quickly. So this is the movie the subject was watching. This is the fMRI brain signals processed. And when it's blue, means the brain is not excited. When it's red, it means it's very excited. So you can see that start with red with a new image or clip and gets cooled down. You see that all over again. The brain is made to get excited with new things. And you see that. New clip gets excited and cools down. This is just a glimpse into how our brain works. We have this hardware with us. So that's something we have to take into account. You can watch that. I'll try to predict things. It's kind of, I think that the variability really excites the brain. So this person probably going to go ask somebody with statistics, oh, remember the AP class this person took in college. And this person most likely going to look up Wikipedia. And that's what Wikipedia says. It's a study of the collection, organization, analysis, interpretation, presenting of data. It deals with all aspects of data, including the planning of data collection in terms of design of surveys, experiments. By analyzing data, it is possible to use one of two statistical methodologies, descriptive statistics or inferential statistics. If you are not a statistician, just try to put yourself in this person's shoes. What this person is going to feel like about statistics. And you do Google statistics. What shows up? Bureau statistics. I was in Australia, so that's why the Australians is using Google Australia. Demographics, and you have histogram, pie chart, no cancer research. No exciting things we do, right? And look at statistician. It's pretty, a statistician is someone who works with theoretical applied statistics. The profession exists in both the private and public sector. It's common to combine knowledge with expert in outside. It doesn't really speak to outside. It's really circular, right? It doesn't really say what we do. And you go on to small jargons. And then Terry Speed wrote a column recently with his experience how other people he interact with think statistics. So other people think that we don't deal with risk with uncertainty. We are too absolute. We do p-value, confidence intervals, defining things like that. And we raise arcane concerns about mathematical methods. And this person said I had no interest in very experienced statisticians. I wasn't even thinking about that model I was going to, what model I was going to use. I think there's a reason. I wanted actionable insight, and that was all I cared about. So people really had this very misunderstanding of what we do. And then how about data science? I actually asked a young undergraduate at University of Melbourne, and he actually was an actuary scientist major, but he said, I don't know much about data science, but it sounds exciting. It's data and science. And it's new. But let's find out. That's Wikipedia. Data science is the study of the generalizable extraction of knowledge from data. Here the key word is science. You decide. And now I found another website. Actually, there are not a lot of searchable entries on data science from IBM. Data scientists are inquisitive, exploring, asking questions, doing what-if analysis, questioning existing assumptions and processes, armed with data analytical results. A top-tier data scientist would then communicate informed conclusions and recommendations across an organization's leadership structure. It's a pretty good description of applied statistics. So imagine you are this J. Let's just give the person a better idea of what the job is than all these jargons. So how many people in this room think this describe what they do? Some percentage of time. And the students who go into the job market will need these skills. And we want to market them right. So it's clear, I think, that if you give people these choices with this information, more people can go to data science. And I know that Northwestern had a master statistics program, secondhand, that they named data science. They just have a lot more application than a traditional statistical program, master's degree, even though the curriculum were very similar. So name does matter. It doesn't mean it's everything. Definitely it's not, but it does matter. So you decide. So why a good new name have power? As I said, a data science master program attracts a lot more applicants than statistics, so you have the talent at your door. And the Mount Snow Foundation already established 3 data science environment centers, Berkeley, NYU, and University of Washington in Seattle. They're giving out DDD Investigator Awards. I think the result will come out in September. And universities are looking into data science FTEs. And industry is advertised for many data science positions. It's just the big environment. We could have owned the name if we just followed people like Jeff, who actually in his inaugural lecture for the cover chair professor in 1998, he had a title, Statistics Equal to Data Science. And he has a proposal. This is from his slides. Statistics, data science, statistician, data scientist. And he had this argument. Several good names have been taken up. Computer science, information science, material science, cognitive science, data science likely the remaining good names reserved for us. 15 years ago, if we just listened, we would have been right in the center. And people who intellectually have been going that way more recent time than Tukey include Leo Bryman. My interest in machine learning had a lot to do with Leo. Again, you can see that, remember all our ancestors had different titles. They were statisticians, they would do something else. That seemed to be a norm. Our top tier people do other things, not just statistics. He started as a probabilist, became a statistician, and then I would call machine learner. And Card, Bagging, Random Forest, all he included kind of his branch his with other people. He said, if our goal as a field is to use data to solve problems, then we need to move away from exclusive dependence on data models and adopt a diverse set of tools. That's very much data science philosophy, right? You just solve the problem. And scientifically, if you think about somebody with a problem, they don't want to separate statistics with computing. For them, it's just all together, right? You want to solve the problem. They don't want to have to talk to people if they could avoid it. One person would be nice, to have everything together, get the concept, get the problem, get the statistical formulation, but at the same time do the computation. And data science really start from, I think they should include data collection, which is a little missing. At least people are very strong with database, data management, and to science. So it includes a much longer, I would say, like assembly line than what we think statistics, right? We didn't touch database a lot. I think should really start from data collection. And the gains for us is we definitely attract more talents, which is crucial, vital for any field, including ours. And secure jobs for our majors. If we have programs, we don't have good market share of jobs, then our program are not really successful. So how to own data science? If we work on real problems, relevant methodology theory will just follow naturally. And then there will be a feedback loop. Right? You will develop new methodology, new methods, and you can apply to or use the other problems, and the new problem will also give you new factors to consider, so it's an iterative process. And the number of fields you can make contributions is huge, right? Genomics, neuroscience, astronomy, nanoscience, now personalized medicine, computational social science industry. And McKinsey had a report 2011 already predicted a shortage of talent for organizations to take advantage of big data. I think there's a lot of news about layoffs of IT companies, but I don't think they're laying off people in data science sector of the organizations. This is an area they need a lot more expertise. So I have a few suggestions for actions if people are so inclined. At the individual level, if you think you do data science, just put data science next to statistician. We're statistician and data scientists. We don't have to give up statistician as a job title. And get on interesting, important projects. Get better at computing, interpersonal leadership skills, playing campus politics. And scale up our algorithms and carry out relevant research. There's also for, I would say, like applied probability people who, a lot of the modern data science algorithms have a random component, and all the analysis statistical property I think are not really analyzed. The CS people only analyze the convergence, but not with statistical angle. So there's a lot of theoretical research to be done as well. And our public image, as I was shown, needs improvement. Everybody, I think, in this room should prepare a 5-minute elevator talk. When somebody, your relative, your friend, anybody asks you what you do, you have something simple, easy, they understood to tell them and show how excited you are. So we, one by one, correct the misconception people say. Usually when people say, what do you do as a statistician? A lot of times people say, oh, I'm sorry. I say, don't be sorry, I'm rather happy. But you have to tell them why they shouldn't be sorry for you. They think you're just doing tabulations, or maybe baseball statistics and things like that. And, oh, that's spelled too. Give public speeches. Do interviews, do blog, do Twitter, YouTube. And update your website so that people from outside can understand what you do. Maybe with a little paragraph, your 5-minute elevator talk on your website. Just take an example to show what you do. And we need to update Wikipedia pages. One thing is if you teach a statistics class, give some incentive for students to go there and update the web pages, the Wikipedia pages. I think we need a lot of work then, because that's our facing window. As a community, that's what I've been doing at Berkeley. We have to write vision statement, white paper, to persuade upper administration and funding agencies to provide resources to us, money and positions. I recall Cochrane started 4 statistics departments, including the Harvard one. If we have that ambition and energy, I don't think we should worry at all. 4, right? 1 person, 4 department. I'm only asking you to do one thing, is to talk to the senior people or just yourself. Make sure what CS does, you know about, and then have something, try to do it with them. It takes some energy from the usual writing paper mode, but it's really, really worthwhile in terms of return for you and for the community. And we definitely need to reform the statistical curriculum. The way we teach intro statistics, a lot of times, really turn people away. I think that curriculum, if you look at it, hasn't changed for the last 50, 60, 70 years. And we need to change that. I think computing has to be in there. So Berkeley will have a team try to work on that. And MOOC is another way to reach out to people. And you don't have to have a whole course of like a semester. A few hours, that would be pretty good. Actually, people like that. A lot of people do MOOC successfully, other people who are retraining themselves. Just have a topic, do a MOOC yourself or with your university support. So what we're doing with IMS, one of my projects as president was to get organized on this conference. It's a IMS and MSR, Microsoft Research, was initiated by me and Jennifer Chase, who is the director of the MSR lab at Cambridge and also New York City. And we have already organized a committee that tried to decide on a date. So the first one, because the venue, and it will be around 50 people, but hope will webcast. Johnson, Idriasi, Kakade, Freeman, Dumas, Monk, and Wainwright. And we really want IMS to play a role of doing relevant foundational work for data science. So you need to bring people together so the more theoretical brains will know what problem to help to solve, and we have a good flow of information both ways. Another thing I did was membership drive. And I had a column, tried to get people in, and it's free, but more importantly, I think this is a human network. Even though everything's online, humans still make the most important decisions. Who accepts your paper? Who reads your paper? Who does your promotion? Who gives you an award? All humans. So don't forget, humans are more important than ever. Because I think the bandwidth between human interaction is still huge relative to what you can do on the internet. So join IMS if you're not a member already. And I was talking to a group of people last night when I bumped into them at Harvard Square to see whether there's interest from young people to start a new researcher group within IMS. This conference has been wonderful, but there's no organization afterwards. And Australian Statistical Society has a young statistician chapter, and I think the Bayesian International Society has just started a young group, and Sonia is saying that maybe there should be some interaction. So that's something I want you to talk about, and if you guys can come up with a proposal, I'll float it with the IMS leadership structure, and hopefully you guys are interested. So keep contact, not just one-time thing. And we probably should have the president of this subgroup sit with the IMS council, maybe with or without voting power, to bring the concerns of young people up right to the council and the president. Another thing we're very proud is that also get more engagement from the communities, that we're opening up the named and medaling lecture nominations to the community, not just by a committee, starting next year. So watch out for the announcement. You can make a difference by nominating people you respect and as a good role models by doing the nomination. So let me remind you again, thinking still the most important, if anything. Compute and lead. And I was talking to a colleague at Berkeley who is just superb in navigating between conflicts, egos of academics. So I thought, you're such a natural. And he said, actually no, when I was in college, I was offended. People were offended all the time by me, but I worked on it. And he's just really, really amazing by now. So it's a skill, doesn't always come naturally. Almost everybody I know who's really, really good seems to have worked on it, just like everything. So don't say that, I'm just not good at it. You'll get better. And you're young, you will get better. So believe in that. Look at people who are really good, they worked on it. It's more fun too if you are good at dealing with people. And up and the people. So this is a list of references. As early as 2004, we already have basically talking about data science. And myself been writing about it, and there's a recent white papers, and this ASA working group came out with a report, and you'll hear from Mike. It's an NRC report on massive database. So, thank you. Yes.
Ben, I think, to me, one of the stress, like when I listen to you, and I listen to you and I think, I can't do all of this, this is way too
It's
overwhelming.
collaborative.
Yeah, I mean, it's like there's so many things I have to be good at, because you listed a whole bunch of ways in which I have to, and I think for me,
You pick
it's
one
been
thing.
really important, yeah. I decide where I'm going to exhibit excellence. And I pursue that, and I just do it the best I can. And at different points in your career, you can pursue excellence in different directions.
Exactly.
But, so the reason why I just wanted to speak up is I think it's important not to get overwhelmed. I mean, because you're presenting, it's wonderful, and but to live up to that standard seems so overwhelming. And I think the key is to choose where you're going to pursue excellence. Don't try and do a low-level job all over the place. Try and pursue excellence in maybe one or two areas.
I think
speak to that?
I think it depends on the personality too.
Yeah.
I think some people is more broad, and there's some talk about pie shape, right? That means you get into two areas, or we call limping pie shape. So more than one area, or T shape, right?
Yeah.
This is all fits different personalities and opportunities. I think it's maybe one thing Susan got me to speak, it's more the opportunities too. These are all the things I want to put on your radar, but it doesn't mean you do all. You're aware of these things, and then when the opportunity arises, you grab for that. You have a good mentor on leadership. Xiaoli just walked in, right? Work with Xiaoli on leadership, right? You use the opportunity, but the thing is I want to put this on your radar so you know what are relevant skill sets you need to have. And then when you have the opportunity, you can decide, just go in there. I would think at least we should do more than one, just because the breadth. Otherwise, we have a silo again. Two, it means you connect it with somebody else. Instead of, if one, you can have these subgroups only in one. But if everybody is like a pie with a limping half a leg, then you connect, and that's very important. So I would say like limping pie would be a good way to see it. So everything's connected, and then knowledge will transfer, and we become, I would call a fused brain. Right? Susan was really speaking to, we have limited brain power, right, and energy. But if we connect together, we can understand each other, we become much, much more powerful. If you look at how engineering has been working with, from undergrad, they're really a team. They're much, much more used to team culture. And the theory people, and I'm part of EECS too, mainly I've been observing their culture. At least the Berkeley ECS, it's really a positive culture. People really collaborate, and they really reach out to the hardware people, the theory people, much less in silo than what we do, because they have to build things together and use everything. So I would think that it's do at least a T, so there's communication. But opportunities, I think, are extremely important, because then you have a leg up to learn something. You have a mentor on something. So watch around, around you who can be mentored at this. Island 2, the leadership, you have a panel, you'll hear more about it. But some people in every department have to take on the leadership. I don't think we have a choice. A lot of time for me, it's almost always like look around and think for a group, then you have to step up. That's how I have run a lot of my choices. It's like the need of a department, a bigger group. Then I have my own interests, but having always a lot, the service is pretty much top on my agenda. I think it depends on the personality, but talk to people and try to get things covered, the interests of the department covered. And in the long run, you benefit your career, because when your department is short of resource, your career cannot thrive. So it's more short-term gain and long-term gain. In terms of long-term gain, we need to make IMS, ASAO strong. That's why we need new members. Did I speak to the question? Thank you. Yes?
I just have a very realistic question. I think America maybe is the country where the statistics is much more appreciated.
Yeah.
And speaking of the jobs in the market now, I'm not do you know if how many data science positions were actually taken by statisticians compared to the computer science people?
I mean, I was
Seems
just
to me
actually.
like many positions was actually taken by people from CS, not actually.
The data science, my guess is probably 15–30%. That would be mine.
Can I say
Yeah.
that? I mean, at Google, we changed the name of our statistician job to data scientist in some subset because that's what people wanted to be called. So I think, I can't speak to the entire industry, but certainly around me, that's what we're looking for when we're looking for data scientists. We're looking for statisticians who have some of these other skills, right? But statistics is the critical level.
So I think it's also like things like that. I think a positive attitude, the can-do attitude. If you don't have information, I would just assume it's over 50%. You go in with that attitude. Nothing to lose, right? You want to own it. That's exactly what I'm talking about. Then it's like oh, maybe we're not, I think we have that mentality for too long. Just go in there and own it, and then find out. So we have the skill set, and pick up the computing, and you are a data scientist. So even when they advertise one, you write your resume to the call, right? You emphasize the part which is what they want. I think the positive attitude makes a huge difference. Because we have talented people. But if we always step back, things don't fall from the sky. So that's what the attitude. We want to own it psychologically, and then we'll own it in reality. That's the first step. There was a question in the back.
So I really like everything you were saying, and I wanted to, when I talk to people about this, also have a story or like a striking anecdote that can clearly illustrate the added value of a statistician to data science as opposed to someone without a statistical component of training. So I was just wondering, in your own experience, or in general, if you had a story that really showed, here's a result that you would get if you did not have statistical training. Here's a result in data science that you would get if you would not have statistical training. And if you do have it, here's an answer that would maybe change your scientific conclusion.
I would think that, again, one area, FDR, right? That's one thing come out from frequentist point of view. And then also, you heard from Don, the causal inference. I was just reading some social science papers, that if you don't take a very rigorous framework in causal inference, you reached wrong conclusion. There was something in political science, I think it was a study done at Yale, about whether making phone calls, short phone calls, would make a difference in voter turnout. And whether you take design into consideration in the right way, it changed the conclusion. So first there was analysis saying that short phone calls didn't make any difference. And then there was a reanalysis saying that you didn't quite do randomization correctly at the individual level, and you follow another framework, and then show that it makes a difference. And later people discovered actually randomization was done at the household level. So at that level, things are pretty much randomized. And you do the analysis with the right mechanism, and then the phone call didn't make a difference. So this is something machine learning definitely doesn't touch yet. I think machine learning people are picking up causal inference. Right, Bernhard, Shankov, that's where the problem. I became interested in causal inference because my neuroscience work, I did predictive work, and you want to do causal inference because you want to know which one drives the brain, and you cannot avoid it. You go to causal inference. So I'm just saying that it's, and a lot of other things like the movie reconstruction work we did, that it's really the brain. Like we did some V4 work with the lab. They are very good computational neuroscientists. And what I think was, I had a really tough brain from my group. machine learner, applied statistician, and we cracked it. And the data has been lying in the lab for 6 years, and they couldn't quite do the modeling. But I don't think that was quite statistical in the sense that it's top talent. That's the most important thing. The field without top talent, you lose. It doesn't matter what's your field. It's not really the field for me, it's talent. It's good versus not so good. So that's why it's so important. We have important problem, but the people are more important. That's why attracting top talent is so important for us. I think I'm pushing the schedule really late, so I probably should finish. Be happy to talk more. Thank you.